Testing, 1, 2, 3. Test. All right, you guys will get the joke later. All right, so lecture 14. What we're going to do this week is we're going to commission what I call a controls engineering lab documentation project. So we're going to put all the skills that you guys have been hopefully paying attention to the last 14, 15 weeks, right? And actually try to do something with those. So some of you guys do that work already, so this should be fairly easy. So for the past 15 weeks, and it wasn't quite 15 weeks because on Thanksgiving you guys weren't thinking about it, but for the past 14 weeks or so, you guys have been working with AutoCAD Electrical, so now is going to be your chance to put those skills to use. We got a brand new controls engineering lab in the other room, Blue 60. Everything is wired up in there. I don't like the way it's wired up in there. This summer we're going to rewire everything. We're going to put in Panduit cable trays between everything and just kind of clean everything up. But what I need a set of prints for my student worker to work off of. So what I'm going to do is you guys are going to create those prints. Now whatever ones I like the best, those become Jessica's prints to wire up this summer. So that's what we're going to give her. So there's 24 control training stations in that room. Only the ones with the green dots actually are fully wired. The green dots, just like the green dots in here, we originally were going to have a lab of 24 students in there. And then as COVID happened, we had to kind of maneuver the room a little bit differently. And when we did that, we spread a few tables to the front and we put dots on every other one. And we made sure that we at least had every other station fully wired. And if you go in there, and I know there's a few of you in here that haven't been in there, I highly recommend on a break or whatever tonight, at least walk in there and take a look at what you're working on. And I'll show you how you, even if you don't, you still can complete this homework without that, because I'm going to give you all the wiring on some scratch paper. So the training stations are fully prototyped. They're functional. Now we need a set of drawings to go with these trainers, and you'll create these drawings. All right. As you look at what's in that lab right now, and those of you guys that are in the PLC class, you'll recognize this stuff, right? So what you're seeing on this drawing is our Allen Bradley L18 ERM. That stands for, it's basically the L18 processor with Ethernet, but it's also a motion controller as well. So that's what the M stands for. You'll see two little modules just to the right of that PLC. Those two little modules are Point.io. Allen Bradley makes an expansion module called Point.io. And what Point.io does is it can add digital inputs, digital outputs, analog inputs, analog outputs. For us, there's an analog input module and an analog output module, which gives us 2 additional points of inputs, 2 additional points of outputs of analog only. Everything on the L18 ERM is digital. Then we have an Ethernet switch next to it, and this is, Kim, why I was so excited to see your drawing you put in there with the switch, because that's actually part of your homework project. There's an HMI, there's an Allen Bradley HMI, I can't remember what model number it is, but it is the latest and greatest HMI that Allen Bradley makes. There's an I/O box down here with all the switches, the push buttons, the LEDs, inputs, outputs, so on and so forth. There's a Kinetics, an Allen Bradley Kinetics 350 servo drive, and then there's a PowerFlex VFD right next door to it. And what's not in there yet, that they're actually in the back table, and my student worker will start installing them next week, are the Cognex Insight machine vision systems that will go right on the right. So that little bottom right corner is kind of reserved for those. What I'm not going to have you do is do a panel drawing of the layout of the panel itself. I played around with that for a little bit and then realized that for whatever reason, I'll show you guys in a minute, like the catalog drawings and stuff for the VFD, they're really accessible, easy to get, and for whatever reason the servo drive, I don't know why I couldn't find it, the Kinetics 350. So there's a few things on here, you know, like the things that are in white, like the Ethernet switch and the Kinetics 350 drive. This Ethernet switch is a German 350 switch. It's like Onric or something like that, or Honric. So you can't find that catalog number. And Mary will tell you, I went through the idea of updating my catalogs and trying to get all of them, and then I crashed SolidWorks, or I crashed AutoCAD so bad I had to get a new computer. So I'm gonna stay away from trying to get all of the catalog information, all the panel drawings, and we're just gonna go with the actual schematic drawings is what I really am after with this project. Okay.
I guess it's more flexible anyways.
It is.
So you don't have to move around.
And the fact of the matter is everything's up there, right? Everything's on the panel already. And what we're going to do is take all the wires down and then rewire everything. So we need to know where the wires terminate, right? Where they start, where they end is what we're after here. So the Blue 60 Lab project, this is the hardware we're dealing with. The Allen Bradley PLC, there is the catalog number, and we'll go through this. So you guys will want your computers open. You will want AutoCAD Electrical open because we will get a start on this tonight. I'll give you a little bit of a demo because I want to talk to you a little bit about non-parametric modeling of PLCs. And then you see the point IO modules. So if you ever wonder what those point IO catalog numbers are, 1734 IE2V, 1734 OE2V, those are your point IO expansions. The Allen Bradley 6-inch panel view HMI is a 2713P. The Kinetics 350 drive, that's the catalog number. The PowerFlex 525 VFD. Now this is an interesting thing. This PowerFlex 525 VFD, when you pull up the drawing off this catalog number, it's going to show you every VFD in that family. Okay, so it's going to bring up like 25 VFDs, and which it's not going to organize them by specific like details of the catalog number. It's going to say, okay, these are all your 525 VFDs. What it's going to organize them by instead is the IP number and the frame. So I will tell you we are IP20 frame B. Okay, so that sizes it out, tells you what environment it can operate in as far as dust, dirt, debris, oil, stuff like that. The I.O. box, which you won't really need, is an HM1541-ND. That's a DigiKey part number. The Lambda DC power supply. Anything with an ND at the end of it is what? That's DigiKey part number, yep. So the Lambda DC power supply, if you wanted to get a 2D drawing of that and throw it into the corner of your drawing or something like that, go for it. There's the part number you could get from DigiKey, and there's the Heinrich industrial Ethernet switch and the part number on DigiKey. So my two favorite vendors, Werner Electric and DigiKey. All the Allen Bradley stuff comes from Werner. Everything else comes from DigiKey. All right, so now what I'm going to show you guys real quick is what I'm going to give you guys to help you with this. These are not the sheets that I want you to create. These are the sheets that I'm going to give you. So what I didn't want to do was do a bunch of AutoCAD electrical drawings to hand you to make AutoCAD electrical drawings, right? That doesn't make sense. So what I did was I gave you what I use as scratch paper in my office to this day is a pad full of I/O listing sheets. Sometimes I'm writing phone numbers on them. Sometimes I'm taking notes for meetings. I go to meetings and I'm taking notes on I/O listing sheets. It's the dumbest thing in the world, but that's what I do. So what I'm going to give you, if you look at the Canvas website for what we're doing this next 2 weeks on this project, I go to ANT 3120, scroll all the way down, and what you're going to see is you're going to see the lecture. That's the PowerPoint that's right there in week 16. You'll see the homework, and we'll open that up in a little bit too. But if you want to open up something right now to look at with me, I'd recommend opening these wiring diagrams. That's the one I want you to open up and take a look at. Now I'm going to download them so I don't have to view them in the Canvas frame. So the homework 14 wiring diagrams, I'm going to open them up separately outside of the Canvas frame just so I can get a better image of them. All right. So when you look at these, I'm using an I/O listing sheet like a piece of scratch paper, like I said. It's not truly I/O, but if you look at this first sheet as an example, sheet 1 of 6, what I'm showing you is the 120 and 24 volt DC distribution for that particular trainer. So we bring in 120 volts AC, we go through a 10 amp what? Circuit breaker, and then we go into a TDK power supply. So, and we've got a circuit, it's a double pole breaker, so we brought both lines, the L1 and the neutral, in through that double pole breaker. And so the line and the neutral both go through a breaker. And then we distribute the 24 volt DC to everything that needs 24 volts DC. So if you've got a bunch of ladder diagrams and other drawings, they're going to come from here, right? That's where they're going to get their 24 volts DC from. I also, though, have 120 volt AC distribution. And what I did here, oh. Is that supposed to be fused? Did you hear me say, oh, right before you said that? Yeah, actually, in all actuality, that actually comes off right here. So it is coming off the breaker.
I thought it was paired off.
Yeah, it's paired off the breaker. So, yeah, the way it's drawn right now, there is no protection, no fusing, no breaker, no nothing. So it does come off the breaker. But I'll tell you what, if you make a mistake based upon something I give you as bad data, I won't mark you wrong. But, yeah. But by all means, go in there and take a look. You know, feel free to go in there and take a look. Kim's got an intriguing question, I can see.
The neutral, shouldn't that just be direct connected?
It could be direct connected, yeah. Yeah, what we've got is we got a double pole breaker, so we just ran line and neutral right into both poles. Yep, just as a nice connection point. Yep.
So in this case, they are double pole disconnected.
They are double pole disconnected, yep.
Can we take pictures of that?
Absolutely you can. Yeah, that'd be a great thing to do.
We haven't worked with it at all.
Yeah, so most of the people who have taken the PLC class have worked with it a little bit, right? And you'll see why I want to rewire it this summer when you get in there. It's a little bit of a bowl full of spaghetti. I mean, it's pretty good, but it can use some help. So we've got our 24-volt distribution network. We've got our 120-volt distribution network, both going out, right? Then you'll notice what I do with that 24 volts. I also have a 24 and a 5-volt distribution network. So now I've got, coming off of the 24 volts, I power up a 5-volt regulator. And I challenge you guys, especially if you haven't seen the lab, go in there and find that. It's a funky little deal. It's kind of cool. It's a 5-volt DIN rail mounted regulator. So we're knocking that 24 volts down to 5 volts. And then we create a 5-volt distribution network. Again, this is scratch paper, folks. This is not an AutoCAD drawing that you're looking at here. But it's something that you should be able to go home and make sense of, to what, especially if you walk through the lab. And then we also have our Ethernet switch right here. And you can see our Ethernet switch also needs 24 volts, right? So 24 volt rails are what I'm using to power the 5-volt regulator and the Ethernet switch. When you look at these screw terminals, the tag that I'm putting on that screw terminal is the tag on the device. So if I go to that 5-volt regulator, one of them will say VN, one of them will say ground, and then the output 5 volts will be plus V0 and 0 volt. That's what the output will say on it, okay? And then the Ethernet switch is just going to have a positive negative coming into it. This is why I got excited about Kim's Ethernet drawing earlier. So, all right. Then I'll go down a little further. This looks a little bit more like what the drawing's supposed to be used for, right? This is what the I/O listing sheet was designed to be used for, was to be used to do PLC I/O. And so that's what we're doing now. So on our actual PLC, you know, if I go back and look at our PLC, which is right here, on our PLC, we've got a number of inputs and outputs, but we also have to power the PLC. So we've got VDC plus, VDC minus, and then we've got FP plus and FP minus, and that represents your field power is what that represents. All right, so you've got positive 24 volts coming into 2 separate terminals, and you've got negative or 0 volts coming into 2 separate terminals. All of those terminals would actually be on the PLC right here, and I think they're right down in this area. I'd have to get a closer drawing to be able to see that. And then you've got your inputs and outputs. So what do we got for this setup that's over there? We've got a stop button. We've got a start button. We've got 4 switches. We have 3 LEDs, and I did test this. These are the correct I/O. Somebody that's in PLCs, am I right on this? Stop is in 0, start is in 1. Does that look about right? And then your red, yellow, and green. Red, to me, it's a little backwards, but red is out 0, yellow is out 1, and green is out 2.
Exactly.
So you guys that have worked with them know what I'm talking about.
I think someone had it backwards, but yeah.
One of them had it backwards?
I think so.
Well, then we'll get them rewired. Do you have it backwards? No? Okay. Then we also have an analog input. There's also a PID trainer that's in there that's not wired up, so I'm not going to have you guys do that. That's what the other analog I/O points are for, is for the PID trainer. You'll notice what I did for the analog input. I wired 5 volts DC through a potentiometer. Anybody have a problem with what I did here? Other than Mary?
Let's see, straight through? That's doing it straight. Just gonna see that one.
Is the analog input ever going to change?
No.
No.
Wiper.
If you think of this as like a 10K ohm pot, you think of this as a 10K ohm pot, all 5 volts, all those electrons are going right through that 10K ohm pot, right? I don't have a voltage divider set up.
In fact, I won't even make it to the terminal. I'll go straight through the wiper to ground.
Well, yeah. So here's the deal. This analog input should be right here. And then this should be connected to 0 volts. Then I create a voltage divider with the input impedance of that analog input. Does that make sense? So that one's a little bit messed up too, but this is where you guys got to fix all my errors, right? So there's 2 so far. The circuit breakers on the 120 and then the analog input. I was going to fix them, but I only noticed that about 30 minutes before class, so figured it was a little too late. Oh yeah, no doubt, yeah.
You're thinking one thing and you write down something else.
Yes, and by all means, if you go in there and you see a different way to do, the other thing I want to tell you about this project is I'm not telling you exactly how to do it. I'm telling you what I want to see, what I'm going to grade you on, but you can take this as far or as little as you want, and you got some creative license, right? So a little bit of license to be creative on this project. So if there's something, if we do it this way at Graco, I'm going to try it this way. You know what I mean? If we do it this way at MTS, I'm going to do it a little bit differently. Maybe you run your power across all the things like I was talking about on those Tesla drawings, right? Whatever it is that you do, I'm fine with that. This is a good time to try some different things and put those skills to use. The sheet 4 is our Kinetics 350 servo drive. Now what you'll see on this is a funky servo drive too. Ready? It's a servo drive that takes 120 volt single phase power in and generates 230 volts 3-phase coming out. Very, very cool little drive, right? So I've got power to the servo, L1 in neutral. You could look at that drive tonight. You could take pictures of it, and you could say, okay, maybe even print these sheets out so you know what you're looking for. UV and W coming out of the servo drive goes to the servo motor, right? And then I also have 24 volt DC input power. So I've got 24 and 0 volt. You'll notice what I did here, right? I didn't want to, this is a 120 sheet, right? So I didn't want to try to pull, I wanted to show that this is coming from 24 and 0. So it's coming from a different sheet. And then all of our encoder feedback. So it's easy to send power down to the servo, right? We have 3 lines going down to the servo and it runs like a champ, right? But when it comes to the encoder, there's a heck of a lot more going on.
You don't just have a plug?
We do have a plug.
Okay.
We do, yeah, and you can put that in a plug. That's probably a better way to show it for sure. Yeah, I will tell you this though. You ready? There's a plug, but there's a plug because me and my student worker had to wire all that stuff in the plug. But yeah, you are correct, Mike. There is a plug.
Oh yeah, a lot of times you buy me just plug.
Yeah, I wish we'd have bought that one. We didn't buy that one, unfortunately. Yeah.
Then plug it in.
I tried to do them both ways.
Yeah, we made it more difficult, and I don't know why they sold me on that one. But you have to take the case apart, and then you have to pull all the wires in there, get them all stripped the right length, get them all routed to the terminals that are in there, terminate them, put the case back together, and terminate the shield inside there too, and then put it together, and then you got a nice plug.
Is it like a spring clip termination, or do you have to?
No, screw terminals in there.
Oh, screw terminals.
It's all screw terminals in there on a circuit board.
It's not soldered.
Yeah, soldered.
No. Now there's something else going on here. So this is a cable that does go to a plug. Yes, and Mike, I am fine with that going to a plug. But what else did I do here? What's this round goofy thing going to a ground? A shield. Why do we shield the cable here?
Lots of noise.
Lots of noise. That's exactly right. Lots of noise. All right, so that's going to give you a good example of what that servo looks like. Now after this, these 2 drawings are probably the most dramatic drawings. After this, it gets really easy. There's your PowerFlex VFD. You've got 3 in, 3 out. Yep.
I left a note on the motor at my station, but there should be a ground on that motor.
Yes, like you're talking about right down here. There should be a ground on that motor. What happens if there's not a ground on that motor?
You can blow it and be hot. Just the case can be hot.
He nailed it. So the reason why we put an earth ground on a metal chassis is if one of these wires comes loose, right, and touches the case, nothing will happen until I decide to come up and touch it. And then I will become the ground for this thing and the safety circuit for this thing. And if it's not grounded, we don't provide a low impedance path back to ground, we won't trip a breaker, we'll trip an EJ or an Andrew or a Sam, right? So you are correct. Is that error number 3 now, Sam?
3 or 4.
3 or 4. So yeah, I would say just like I did in the last one, really the chassis of all these motors should be grounded. Yep, so, and I think I actually meant to do that the other way around, but that's fine. So this one's really, really easy. All we have wired up is the 120 in with a ground, and then the 3 phases out, T1, T2, T3 to the 3-phase motor. And you'll see that when you go in there and take a look at it. And then last but not least, your easiest one to do is your panel view HMI. All you got to do is power the device up. Now, I will tell you, all of these devices are also connected over Ethernet, right? And I don't know, what do you guys do at work for Ethernet?
It depends on how big the cell is.
Okay. Yeah, typically I see that there's an Ethernet switch that gets wired up because it's using power. Typically we're not showing those Ethernet communications on these drawings though, right? Because it's just plug to plug, right? So, all right, so there are your 6 wiring diagrams. And there's a few little idiosyncrasies, but I think for the most part these are pretty darn good, and they're going to be your best path to completing this. Now maybe before I jump into the other part, maybe I'll show the homework real quick before we jump into a short little demo, because I do want to do a little demo with you guys as well. So if you open up the homework 14, which is also on the same Canvas page, and I'll put it up on the board. So attached to this homework, you'll find catalog numbers, wiring and I/O diagrams for the trainers in Blue 60, or to create a set of prints that can be used to assemble and wire these trainers. I also want to see a picture of the hardware device on each drawing so that my student worker knows what device she's working with and she can wire off of it. I'll show you that in the demo as well. This is my recommendation. I'm not going to give you a real hard time if you stray away from this a little bit, but I do want sheet 1 to be a table of contents. I want it to be a list of the sheets. So I want to list the sheets on page 1. Show me what this packet of prints is. Right, table of contents. And then page 2, I've got a list of parts. And I could even be, I don't know. That let's go with that. 2 sheets. And then page 3, I've got power distribution drawings. So all of your 120, your 24 volts, and your 5 volts, how we build those powers with a regulator, with a power supply, the 120 coming in through the circuit breakers, all of that stuff should be on that power distribution drawing. Sheet 4 will be your busiest sheet because that's going to be your PLC sheet. So that'll have both your what's that? They're both 4. Yep. Yeah, so sheet 4 will include both the PLC CPU and the analog, I see what you're asking, and the analog point I/O. So all of this stuff that's right here, so and you don't have to include the analog output module. There is an analog output module there, but it's not currently wired up. So for right now, I'm fine with you just including the 1734 IE2V, because that's just the analog input module. Then I've got a sheet for the panel view HMI. That's almost trivial. You could, if you wanted to, you could put that on the same sheet as the power flex. There's very, very few components on either one of those. The servo drive, on the other hand, does have a lot of stuff going on in it, so it'd be worthwhile to look at that one and at least kind of know what we're looking at. And so grand total, we're looking at 50 total points. So this is the equivalent of doing like 2.5 of the homeworks, right? So it's so I'm going to give you 2 weeks to do it. So you won't have a homework next week. And I actually got this down here. I'll assign the final project tonight. Next week we'll review for the final exam. So my recommendation to you is get a start on this homework this week, because when you're at home and you're working on it, you're like, what is he talking about? You know what I mean? Because you'll do that, right? You'll be looking at the I/O listing sheet and you'll be looking at what it's asking you to do. You'll have no idea. You can come in next week. You can go take a picture. You can come ask me. You got another whole week to work on it after that. So you can get what you can get done. You know, power distribution sheets are easy, right? The HMI and the power flux, that's going to be 5 minutes worth of work. But then when you get to something where you're like, I don't know where that wire goes, you know, and so you bounce over to the lab and take a look and see where it actually goes. And so that final project will be due at the same time as we take our final exam. So next week we'll just do a review for the final exam, and then the following week we'll take the final exam and I'll collect those final projects. So what I'm expecting is a pack, pack of papers, pack of sheets, a set of drawings that's going to tell someone how to wire those up. So what I'm looking for, things like table of contents, including sheet number, file number, description, title block updated using the Dunwoody template, each sheet printed on 11 by 17 paper, single staple in the upper left corner, folded over correctly, correct I/O devices and symbols used, like that potentiometer that I showed. We've never put a potentiometer in a drawing, but they're actually easy to find. In the icon menu, they've got like an electronic components sub-menu, and in there you'll find potentiometers and some other electronic components. PLC I/O addresses identified. That's going to be important. Appropriate tags used. Power rails identified, labeled. I do want a DXF or 2D drawing on each sheet. So if the sheet has the PLC and the point I/O, I want to see that on the sheet. So someone looking at this knows, okay, that's what I'm wiring on this page, is what I'm looking at. Source and destination arrows as necessary. And then, and think of the source and destination arrows. If you're looking at like coming from the 24 volts DC off the power distribution sheet to the 24 volt rails on the PLC sheet, right? We ought to have that connection made. All wires neatly routed. So that's what I'm looking for, is a nice clean set of prints that I could hand this to my student worker and we could rewire all of those this summer and get her a ton of hours. So what do you guys think? Not too bad?
You aren't picky on like wire numbering, are you?
I'm not picky on wire numbering, and I didn't include this. I won't take off for it because I didn't ask for it, but I'm not going to be picky on wire numbering. I thought it would be good to include wire colors at some point in the drawing, whether it's on the power distribution sheet if you wanted to show me that this is a black wire, a white wire, a blue wire, white with a blue stripe wire. I don't want every wire to be labeled with something, right? But yeah, I won't be too picky on that stuff. Yeah, really this is about identifying components, tagging things properly, and giving me a set of prints that someone could actually wire this thing back up again if we needed to.
Would
All
it
right.
be helpful if we did, I think most of it's 16 gauge or 18 gauge anyway.
It's all 18 gauge stranded MTW. You could make a note somewhere, if you wanted to, in the list of parts or something if you want. I don't know. I'm trying to think of an easy way to do that. But yeah, I'm not going to ask for a wire layer where I can click on the wires and show all of the, plus I'm not even going to get, I may ask you for your electronic files if I really like them.
That's easy. You just copy the folder.
Yeah.
I make it in a new folder and you should be fine.
Yeah. I mean, at some point, it will be really nice to have that. And for those of you that are going into PLCs next semester, or for those of you that are going to the motors next semester, this is a good activity because it's going to give you an idea of what are the components that I'm going to be working with next semester. What is this Kinetics 350 drive? What PLC are they running in that lab over there?
Can you rewire it?
No. We're going to rewire all of them this summer.
Yeah,
so,
exactly.
so yeah, if you want to rewire 24 of them. All right. So now what I want to do is I want to open up AutoCAD Electrical real quick. So let's do that. Because I want to talk a little bit about working with a non-parametric model of a PLC. And I think I did this a long time ago, like week 5. We talked about using the parametric models of the PLCs and actually dumping those I/O modules right onto your ladder and worked out really good for us. All right, so I actually created a nice little folder here. Not a bad idea to create a new project and call it Blue 60 Drawings or AE project or whatever you want to call it. I would highly recommend creating a new project and say this is where I'm going to put those new drawings that I'm making, right? For me, I created one. I created this project Blue 60 Drawings. That's probably a good name for it because that's what we're drawing. We're drawing the components in Blue 60. And when I talked about putting like the component with the schematic, this is what I'm talking about right here. I've got my title block, I've got my ladder, I've got the component, and I've got my schematic. So what I'm going to do is I'm going to start off by creating a new drawing. And I'll call this, I don't know what I'm going to call it. I'm just going to call it L18ERM. That's the PLC that we're working with. I was going to call it PLC drawing, but apparently I already used that. So L18ERM PLC, I'm going to hit OK. Make sure I've got the template that I want. And for me, it's the Dunwoody AE template. Some of you guys have actually cleaned up those templates and actually made them even better. I say awesome. Absolutely awesome if you found a way to make it even cleaner and work with it. All right, now before I do anything, what I want to do is I want to go out to the internet. All right, so let's go to a browser window. Any browser window, I want to go to Rockwell Automation. Because one of the things I asked you to do for this project is to go out and get that DXF of the part, right? So I want you to go out and get that DXF of the part. So the nice thing is, I gave it to you in two different places. I gave it to you both on the homework, and I gave it to you in the PowerPoint too. I gave you the catalog numbers. And if you're still unsure, you can go into the lab at any time you want. I'm here all the time. I can let you in there if it's locked. And you can even let security, if anybody ever had to get in there and I'm not here, if you tell security you're working on a project for EJ and you just need to get in there and get some part numbers, they can call my cell phone if you need to get in there. So you can always get in there. We're not open on Saturdays or Sunday during COVID, but in the future we would be. So I'm going to take this catalog number right here, this 1769 L18ERM, all right, BB1B, and I'm going to go into under support. When you're on the Rockwell Automation, rockwellautomation.com, that's where I went, rockwellautomation.com. And when I get in here, under support, there's 2D and 3D drawings. So I just kind of mouse over support, and I go down to 2D and 3D drawings. And then all I'm going to do is go look for that catalog number. So scroll down a little bit, and you can paste that catalog number right into the search block there and see what you find. It has this funky little... instead of like a spinning wheel, it's like a spinning bubbles or something. And then it's going to bring this up. Now what I'll tell you is what I want is a DXF or DWG file. I do not want the three-dimensional step file. You could, I will tell you, if you ever wanted to, like on the, I think it was on the Kinetics 350 drive. They didn't have a DXF drawing in the catalog, but they had a step drawing, a 3D model that you could open up in SolidWorks. And I actually went so far as opening it up in SolidWorks, then creating a drawing of it, and then having it, and I was like, that was way too crazy. So that's why I kind of got away from getting too crazy on this. What I want to do is open up this 2D drawing, DWG, DXF, and that's going to open up right into AutoCAD Electrical, just like what we've been doing. And it's going to give you the orthographic views. How about you guys that are in Intro to Engineering? What were we talking about last week? Well, we were talking about Turkey last week. Yeah, the week before we were talking about orthographic views and engineering graphics, right? That's what we're looking at, top, front, side, and an isometric of our PLC. So I can zoom in on this guy if I want. If I just want to get a clip of him, I can just, kind of mouse over him here. And I can just copy him over if I want. And I can paste him right in here. And I might get some extra little junk if I'm not careful. Now, here's something kind of cool too. When he comes in, if you don't like the size of him, because I'll tell you what, when you bring in the VFD, it comes in huge. It comes in monster. This one's actually coming in a size I like, but you can right click on this guy. And am I wrong?
You didn't. You might have to highlight the whole thing.
Oh man. Yeah, you should be able to right click on this guy and go to scale. See that? So if you right click on him and go to scale, then what you can do is you can go anywhere on him. You can, like when you get the little X here, you can left click and drag, and you can make it bigger.
So it's nice is if you leave the dimensioning on there, you can get it to the right size. That's how I did my panel before, and you do that for 50 components and you get sick of it.
Oh, no doubt.
So
So if I want to make him the right size,
yeah, you leave the dimensions on it when you copied it, or put new dimensions on it now, and then scale it, let it sit, and then you'll see what dimension that actually is.
how do you do that?
I would just copy it in with dimension. Let's see if I can do it here.
Can you copy it in with dimensions?
I think so.
Like highlight the whole thing with its speeder
Yeah.
lines and everything.
So you need all of this, you're saying?
Yeah, so as you copy that. You can just rescale it there and you'll see what happens. So just
Oh, I gotcha.
highlight all of it with the dimensions, scale it, and that will actually show the dimension as you're moving. So if you're like 96 to 1,
Oh, that's outstanding.
or if you're metric to
Look at that. Isn't that beautiful? So he's right. Mike's right. I mean, so
and
as
delete them once you get there.
and so as I'm moving it around, it's actually giving me the exact dimensions I want. That's outstanding. I love it. All right, so we learned something. I'm gonna.
Sometimes you quickly make it way too big.
Yeah, don't go far. Yeah.
You accidentally type a number like 1,000 in there, and it's as big as the room.
Well, I had it where I made it so it's like 0.01,
Oh, jeez.
and it's just tiny. Then you
Can't even
zoom in-
find it.
Zoom in for date. Yeah, you take this big thing. Now you
It's
gotta
a
find
dot.
it. So you want to make sure you try and get like the center in the drawing if it's huge.
All in metric and you're
Yeah, and
Oh
you
my
were just
gosh.
trying
That's probably the worst.
millimeters to inch.
Yeah.
So really, really cool. The thing to know, you can scale that. You're not stuck with what's coming in. You can scale it to what you want it to be. That's outstanding, right? All right, now what I'm going to do is I'm going to go back and look at that IO listing sheet. It's in my downloads, I suppose, huh? Let me go look at my downloads. There's my wiring diagrams. I'm going to go look at this IO listing sheet for the PLC because I want to know what the heck was I going to do with this PLC, right? So here's the IO listing sheet for my PLC. I can zoom out a little bit on that and know what I'm looking at. Now, what I will warn you of is when you go into the parametric, inserting a PLC parametrically, you're not going to find this PLC, all right? This is where I went in and tried to update my catalogs, and it just became more messy than it needed to be. So for this PLC, you can also do a non-parametric model. What that means is I'm just going to insert a ladder diagram. So I'm going to grab a ladder, and I'm going to go bigger than I normally do. I normally take the width out to 4.5 or 6. I'm going to take it out to 7.5.
12.
I know you go out to 12 on these things. I'm going to go. You can still go to 12. I'm going to go out to 7.5, and that, to me that's huge. And Mike's like, that's tiny. All right.
No room.
Yeah. And then I'm gonna pull this down and just get some ladder rungs in here. 40 of them. I don't know how many I'm going to get in here. All right. And then at the top, I'm going to go ahead, and I can see I'm kind of already all over the place on this thing. I'm going to put some, for right now, I'm just going to put some reference arrows, but you would be connecting this, right, to your 24-volt distribution system. But for right now, I don't have a 24-volt distribution system, so I'm going to put a tail up arrow here and call it plus 24. And I'm going to put a tail up over on the right-hand side. Reference arrow only. And I'm going to put a 0 volt. Just like so. Okay, now I'm pretty happy with both of those guys. Got my 24, I got my 0 volt. You guys better with one more light off? As I look at the board, I can see it gets hard to see. So I'm going to go ahead and turn one more off. You guys might be a little better off. All right, now what I need to do is I need to get this VDC plus, this FP plus, so on and so forth. So what I'm going to do is I'm going to go to the icon menu now. Instead of using the parametric model of the PLC, I'm going to go into the icon menu. I'm going to go to PLC IO. And in PLCIO, you've got inputs and you've got outputs. You've got first wire, one wire, first wire, or first point, one wire, first point, two wires, so on and so forth. One wire, two wires, so on and so forth. But pretty much all we need is the in and the out. So I'm going to take this in, first point, one wire, and I'm going to place that guy right smack dab in the middle. And don't worry about lining them up, because you guys can always align them later, right? You just want to get what you need in there set up. Now this is where the IO listing sheet comes in handy, because I want what's on the PLC. I don't want to put 24V, because when the person's wiring this up, they're going to say there is no terminal called 24V. It's called VDC plus. So I'm going to put the tag for this as VDC plus. And I'm going to hit OK. You'll see as soon as you do that, it gives it something called PLC 51. Where's that 51 come from? The rung number. And it goes in and labels that screw terminal as VDC plus. Now I don't want to have every single one of my screw terminals labeled PLC 51, PLC 52, PLC 53. So I'm going to change this tag PLC 51, and instead of PLC 51, I'm going to call it AB, I don't remember what the number was, 1769. I'm going to use the catalog number, 1769-L18, 1769-L18, ERM-BB1B.
The tag number you're changing?
That's the actual tag number. The reason I'm doing that, so now I can say, okay, this is that particular PLC or that particular module, whatever it might be. That's where these terminals are going to be. And I'm not going to label the rest of the terminals. I'm just going to use that as my, and you could put text up there. You don't have to have it be the tag for the first terminal. But in my case, it's going to.
One thing you might want to do is make it fixed so it doesn't auto-update.
Ooh.
So right-click, go to Edit Component, top one, and there's a little tab that says Fix.
Yeah.
Do that. That'll save you some time.
Otherwise, and that's fixed only for that first one, though, right?
Well, it'll be fixed for that.
Yeah.
By that one. So if you make this a parent and all the siblings, it'll be.
Yeah. So what Mike's saying is, if I change something in here and all of a sudden the rung moves, it may ask you, we're going to update the tags for you, and automatically it's going to overwrite that tag, which is not going to be helpful to me because I don't want that tag overwritten because I'm really not using it as a tag, right? I'm using it as more of a description is what I'm using it as. I like that. That's a good call there. Did that change its color too? That's nice. All right. So now I want to go ahead and put in another terminal. And if I go back to my IO listing sheet, I can see FP+. This is my field power supply. So I'm going to go back into my icon menu. And now I've got this first point one wire. I can just use this same exact one, place it right here, and it was called FP+.
So, quick question for you. Why wouldn't you use second plus wire? Would that be...
You could.
Okay.
Yeah, you could.
I'm just wondering if you messed around.
I haven't messed around with it. Yeah, I typically just use one wire, one point, all the way down.
Okay.
Yep. You know, the other thing you can do, check this out, and this is a reminder, check this out, Mike. You can also do this. See this place multiple?
Yeah.
Multiple insert? Now, I'm doing it at the wrong time right now because I'm only going to do one more of these, right?
Yeah.
But if I do multiple insert, I can actually grab this first point one wire, and when I click on this, I'm going to click there, I'm going to click there, I'm going to click there, and when I hit enter, it's going to go ahead and ask me for each one of them, and I just can type in the tag areas. I don't want to do that though, so because I'm only doing one more for the power, right? So but when I get to the inputs, that'd be a great time to do it, right? Because I'm going to do 6 or 8 of those in a row. Why keep clicking around, right? So I'm going to go back to the icon menu, and I'm going to go to that first point one wire, and I'm going to place that guy right there. And now this guy for the tag is going to be FP+. So that's my field power plus. All right? What does that mean when I say field power? Yep, I'm doing field power plus as the tag on that. Oh, no, I don't want that as the tag, do I?
No.
I want it inside. Sorry about that. I don't want that as the tag. I want that as
Yeah, go to edit component.
edit component. I want it as the IO address is what I want. Sorry about that. There we go. FP plus. Yeah, I don't want that as the tag. I want that as the IO address. The tag is going to go outside of the terminal above it. The IO address is actually going to go with the terminal. So now it's labeled with the terminal. And that's really what we're looking for, is what's the terminal labeled as. Now is a point where I could do that place multiple if I wanted to, because I know I got 2 negatives coming. So I'm going to try it. I'm going to do the multiple insert just to try it once. I'm going to go to multiple insert. And in my icon menu under PLCIO, instead of the first point 1 wire in, we're going to do the out first point 1 wire. I'm going to place one right here. And then I'm going to go down from there. And I'm going to click. And now I mean, it's really kind of useless to do 2 of them, but
Yeah, it might not work for you too.
I'm going to hit enter. It says keep this one. I'm going to say yep. And it's going to say, what's your IO address? Okay, the IO address of this is VDC minus. You know, I wanted to say it's 0 volts, but you want to be careful here because the IO listing sheet actually has that screw terminal label. That's what I want to use is VDC minus. And I don't want the tag, so I'm going to get rid of the PLC53 tag. And I'm going to hit OK. Now when I do that, it's going to label that one and bring up the next one. It's going to say, I got one queued up. You placed multiple. Okay. I'm going to hit OK again. Instead of VDC minus, this time it's going to be field power minus. Field power minus, and I'm going to delete the tag again. And you don't have to, oh, look what happened. Now I got a PLC 54 in there. But I can get rid of that, right? That's easy enough. I can just double click on that. Go in here, where's PLC 54? It's right there. Get rid of that thing. And now I got everything I want. That's what I want it to look like. All right? You guys are going to have a lot more work than this, right? I'm not going to do, I'll do one more because I don't want to do the whole homework on the toughest sheet that you're going to work on. So that's, not to mention we haven't done any source destination. We haven't done anything significant. But what I would do next is I would go to the IO listing sheet and I'd say, oh, I need that stop push button now on in0. So now I would go find in my icon menu again, I would go find PLCIO, and actually it's in my recently used items, in. I'm going to place it off center a little bit. Why? Because I can show you the align tool then too, right? So I can place that off center a little bit. And now when I look at the IO listing sheet, the screw terminal, the label on that screw terminal is in0. So I want to call that in0. So I don't want a PLC tag, but I want this to say in0 as my IO address. And when I hit OK, there it is. And let me do one more. Oh, no, I still got to do a component on this, right? Stop push button. So I'll go to the icon menu. Icon menu, push button, stop push button, or normally closed. It's not an emergency stop, it's just a stop. And now I can tag this. I could just leave it as PB55, which I'm plenty happy with. I could. I'm not going to ask you guys to do this. You could actually go select the component in the catalog, right? What I will tell you, though, is right now the only catalog you have is the Allen Bradley catalog and like, what was the other one we had?
A little bit of Siemens was in there, I think, too. And
Telemechanique, yeah. So we only had a couple of catalogs, and I can guarantee you what I'm using in the lab is not in any of those catalogs. So I'm okay with you guys doing these prints without catalogs, and I can hit OK, and now I'm sitting pretty good. Now you might say, don't worry. What I was going to say is don't worry about getting these things lined up, right? Because it doesn't matter how they line up, right? What can I do? So mine are all out of a line right now. I just right-click on this first one, bring up this marking menu, and I go to align. I go ahead and I click on every one I want to align with that. Click, click, click. So now I've got my alignment tool, or my datum is that first one, right? I selected the other 4 that go with it, or in the case of the IO listing sheet, I'm not going to have 4. I'm going to have 4, 8, 12, 16 screw terminals on this one module. All right. Now, mind you, but they're not all 16 on that one module. One of them is the point IO, isn't it? So I need a separate source. I need a 5-volt set of rails for the point IO. So don't get confused about that. But as soon as I do this, I can hit enter now, and they all lined up perfectly. I don't have to worry about how I'm going to do that. The other thing I can guarantee if you want to lose points on the project is leave this type of stuff, right? On that stuff we did like in week 5, we were all like, wire up that parametric model and just leave these extra rails connected down at the bottom. Don't do that. Shorten the rails up, make them the right length. Delete the empty rungs that you need, and even the empty, even the empty rung numbers can go away too, and the little rung nodes too, because I see that a lot too, where people will delete these, and then they'll leave that sitting there, and there's no need. You get rid of that stuff is as easy as just drawing a box around it, hit delete, and you're done with it. Yeah.
I would argue to leave the wire numbers in case of like red lines and things.
Yeah.
So you're saying leave those?
Leave the numbers, not the dots.
I like that idea.
Add anything.
I like that idea. Yeah, you could legitimately pencil something in later if you had to, right? Yeah, I like that. Yeah, good call. Good call. How you guys feel about that? Not too shabby?
Pretty good, pretty good.
And then we would need a set of 5-volt rails over here. Let's play with it for a second here. Maybe not right over here. Maybe it could be on the same page. I could, if I needed to, I could put it, I guess I could put it down here. I was going to maybe put it underneath without doing exactly what Sam asked me not to do. If I end up, maybe I do have enough extra stuff that I can leave some extra wire numbers there. But maybe down here I want to put a separate set of rails where I want to do 5 volts down here. So I do this same 7.5, and now I have a 5-volt set of rails down here, let's say, right? The only reason why I wanted to show you that is on the icon menu, the components we've been using, push buttons, switches, pilot lights, relays, contacts, limit switches, solenoids. We've been using almost everything on there. The one thing that we haven't touched, and now I don't remember where it is, there's an electronic components one. Where the heck is it hiding?
I think it was right there. Just whatever you close right now is somewhere inside.
Under the miscellaneous?
There it is.
Oh, yeah. The electronics. So like if I'm looking for a potentiometer, I can just go into this electronics section, and now I have a variable resistor with the wiper facing up, or a variable resistor with the wiper facing down, or I have a variable rheostat with like a round section to it. But they've got diodes and rectifiers and other stuff in here that you can use as well. So if I wanted to use this, and I wanted to use it correctly, unlike what I did before, I would maybe grab this variable resistor, put it right here, and I'll let it come in as VR66 or whatever. I'm fine with that. And then what I would do is I'd bring in that analog input, and I don't know what the analog input's address is. I guess I can look. I'll go to in first point, and I'll put it right here. And the analog input's address is AI0. So I'm going to do AI0. I'm going to delete the PLC69. Now I've got AI0. And if I want to wire down to that, it's as simple as that. And then trimming the wire. And now I have an analog. And there should be a common. There's other things that go with that, right? But I just wanted to at least show you guys where that variable resistor was. And where some of those other, there's lots of other electronic components in there that I think people don't even realize they're there. It's under miscellaneous electronics. And I don't know that you use a whole lot of them. But there may be some times if you're dealing with signals where you might use, we use shields to eliminate noise. We also use capacitors to eliminate noise as well. And sometimes we use capacitors as backup batteries too. So I mean, you may end up needing a capacitor or a Zener, or there's also many times we use diodes with relays. What do we use diodes with relays for? The coil of a relay.
Polarity protection for one thing.
You do polarity protection, but you can also get some EMF kickback. So a lot of times we'll put a diode in parallel
With a coil, yeah.
with the coil. So we do stuff like that as well. So so just know, it's good to know that if you need something like that, it is available in here. I would say normally you probably aren't going to use most of that stuff, but you do have it available to you. So
See the Schottky diodes for coils, though. That's
Schottky diode, yeah. There's
like they put the
oh my
Zener.
God, there's so many diodes available.
I wonder
And
if they use Zener diodes in those little 5-volt
regulators.
Yeah.
They use something called a 3-pin regulator. It's a 7805 regulator that's internal. That'll take any voltage, 8 volts to 24 volts, and it'll turn it into 5. So now what I would want to do on this, make sure when you go to do it, is that you do actually have, reference arrows for this one too. I don't want someone to think that this is a 24 volts, right?
Yeah.
I want someone to know that, okay, that's the 5-volt circuit that we're working with. And really, we really want to use a 10-volt circuit, right? Because our analog inputs are usually based upon a 0 to 10-volt circuit. For whatever reason, I couldn't find a really nice DIN rail mounted 10-volt regulator. And so I was talking to Anjana about that, and she says, well, they can scale it to anything.
But you just buy a power supply.
I could have bought a 10-volt power supply.
I wonder, do they make one that goes -5? Because then you could have negative and plus.
Absolutely. They make the 7805 is a 5-volt 3-pin regulator, and a 7905 is a negative 5-volt regulator. So yeah, they make all kinds of stuff.
Sweet.
So this is kind of an example of what I'm looking for, right? Now, when you go to do another sheet, like as an example, if I was going to go do the PowerFlex 525, right? I've got this catalog number. So I can go look for that catalog number on the Rockwell website. Again, I can go back to support, 2D drawings. I was actually on the page. I don't know why I just did that, but that's fine. And then I can scroll down to where I type in the catalog number again. This is the one I was warning you guys about, right? There's 2 issues with this one. The first issue is when I go to this DXF for the VFDs, watch what I get. I'm going to open it up. It actually gives me a little zip folder. And in that zip folder I get, yeah, that's the right one. When I go into this, it says it's going to come in as read-only. Look what I get. I get the entire product line for PowerFlex, which is fine. It's, it's very good. But how do I know which one? You know what I mean? I don't know which one we actually are using. Well, what I do know is I did give you, based upon me going and looking at it, it's an IP20 frame B. So that's just me going, and this is what you guys may have to do. I didn't do this for everything. You may have to go out there and search and say, okay, what model number is this? What is he looking at? You may have to pop into the lab and take a look. IP20 frame B. So if I go back into there now, I can see IP20 frame C, IP20 frame B. This is my guy right here. And Mike, are you telling me I can scale this guy too?
Yeah. Go with it. Yeah, you can pre-scale it. So are you in? Yeah. So it's,
look how big these things are.
It's in metric right now. So and your panels in standard.
Yeah, watch this. If I paste this in, watch this. This is where it gets interesting.
Do it like not in the middle.
Do it somewhere else.
We'll do it like not that far up, just a little bit.
Oh, because we want to see it,
You
right?
want to see it,
You ready?
but you don't want to lose it.
There it is.
Ooh.
So there's my VFD right there.
Heard that one.
Yeah. Print expense. Or rather, yeah, plotter.
But
The
the
scale's there, so it's just really small right now.
so what I can do though is, like Mike's saying, I can go ahead and highlight all of that,
Yeah.
and then I can right click on it, and I can go to scale.
And this is where you might lose it if you go, yeah, too small.
So I can.
See it? So it's way up there, so you kind of want to scale from the corner, so you're right down by
Yeah, I shouldn't have done that.
Yeah.
But I'm
But
okay.
you're big, you're good.
But look, I'm looking at the drawing down there and kind of comparing it to what I've got drawn now, and now I say, oh, that's pretty close.
Yeah.
You know.
It's
So-
still pretty big.
Let's see how it
You
comes
wanna
in.
Move it into there. Yeah.
Whoa! But you guys get the idea what we're up to there, right? So these things are not always going to be very friendly, is what I would say. Sometimes they're going to come in like that PLC came in really nice, didn't it? It was like almost built for our drawing. We scaled it a tiny little bit.
It's just in the scaling they saved it.
Yeah, exactly right. And so then the other problem you're going to have is if I go back in here and I look for the Kinetics 350 drive, here's the part number. All right, there's the part number for the Kinetics 350 drive, and I go into the search, hit back to my catalog, and I search for that catalog number. What you're going to find out is, yeah, it'll recognize the catalog eventually. This is why people do like Allen Bradley, though. They do a really good job of keeping the catalog numbers together. For whatever reason, they don't give you a DXF on this guy. They give you a 3D model step, which will open in SolidWorks, that you could do a drawing from. They give you an installation, a user manual. Yeah, so a lot of times some of these manuals will actually have a nice little 2D drawing in them.
There it is.
Where is it at?
Page 6.
I went past it already, huh?
Yeah. Which one did you go in? Oh, I went in the installation manual, not the...
Did you go into installation manual?
Yeah, installation.
I went to the user manual.
You skip the user manual. It's just the installation. One more.
Oh, there we go. Now you can't bring that in as a scalable model, though.
No.
But what you could do is you could copy that out and paste it in there. And if you look at what I did in the PowerPoint, that is why you see it coming in as a white item. See that? So you see that the scalable models are coming in as this wireframe, and the little Ethernet switch.
So invert the coloring of your image
And you'd be good, yeah. But again, this is why I'm not asking for a panel drawing, guys. I'm not asking you to do what this is. This is available to you to kind of know where the components are sitting and what they are and kind of what their size relationship is and stuff. But I'm only looking for you guys to put those on the drawing like this. That's really, really what I'm looking for. What do you guys think? Not too bad?
Pretty good.
So here's what I recommend that you do. We legitimately got another half hour left of this class. What I think you ought to do right now, if you got a moment, is maybe print a set of the I/O listing sheets, walk into the lab, especially if you haven't done the PLC stuff in there. At least walk into the lab and take a look at what the components are. So you can kind of say, okay, this sheet is talking about that thing. This sheet's talking about that thing. And you can even, and this might be a thing for everyone to do, even if you don't print out the I/O listing sheets, might not be a bad idea just to go take a nice picture of the entire layout of it and put it on your cell phone. So now when you go home or whatever and you're looking at this, okay, that's what that is. I can see what he's up to. Now, what I didn't put in here, there's jumpers for dynamic braking on the servo or the VFD. I mean, there's all kinds of extra little goodies that I didn't put in there. So I'm not going to make you guys wire that stuff up. Really, the bulk of it is I/O, power. I guess the bulk of it's I/O and power. Some feedback cables and things like that. So, make sense? All right. So what I'm going to do is we're going to take a break till 7, but that's so that you guys can pop in there, take a look, take pictures, print out I/O listing sheets if you want, and get a little bit of break time if you like as well. And then you got something to work with this week as you get started on this. All right, that's it.
I assume your 24 volts out is fused, right?